Hello, good day. This is Human Error with a new repair today. Let's turn on some more light. I got this expander 24 in-out interface from someone who received a replacement transformer from me. It was turned on while it was set to 110 volts, and it doesn't say a power rating on the outside. Oh yeah, here it is. Here is the switch to switch between 230 and 110. As he said, it was set to 110 while connecting to 230 volts. That's obviously not okay. So the transformer actually burned. I don't know. It just got too hot. He replaced the transformer that he got for me, and when he turned it on again, smoke escaped from the machine. So we're gonna open it up and see what we can find inside. These are long screws. Are we missing anything? No. Won't open up on me. There's one screw missing here. Why? Why, oh why is it? Maybe it wants to be opened up the other way around. So let's give that a try. It's the first time I have this expander here. I've worked on some MOTU interfaces before. Screwed one up once. Well, I think that was just coincidence, because this is actually the top lid. And here we are. I can already see the new replacement, and I can also see the discoloration on the other one. Wow, some interesting heatsink over here. The word connector is broken. Can I give you a bit of a better picture? No. That's the thing, I'm doing this live because it would take too much time to edit all these kind of videos, but yeah, it does have its consequences. Not the best videos, I know, but I do my best. So at first glance, this looks pretty much alright, but I'm also not wearing my glasses, so Let's start with it. I'm getting old, I need glasses. Hey. And he said he found a blown, whatever, he sent me some pictures. He told me it was underneath here. These are just Phillips as well. That is really small. pH. And I think this is pH 1. Am I right? Where is it 0? Ah, it's 1. And this is 2. So it's a ton of screws in here. I don't want it to move around, obviously, which is a good thing. Yeah, it's a good thing. Right, this is probably connected with some headers. Press fit. That's better. Not forgetting any screws. No, doesn't look like it. Can I lift this up and then move it out? No, it actually wants this entire thing to come off. Here we go. And they're all still straight. That's nice. Always do a little bit of visual inspection. Looks fine. And well, here it is. And let me see if I can bring that closer to you. It's really difficult to see. It's actually right. Come on. You can see the scorches over there. It's a little bit brownish. It looks, yeah, it's a cap and it's already off. It's no longer there. It's on a big trace, power trace, because all the other traces here for the audio are much smaller. This is a white trace, so it would suggest. And he sent me a picture in advance and I said, yeah, it could be a bypass cap, just to filter out the power rails, and it could very well be alright, but I don't want to just turn on power on here and just hope that it works. So I want to my second camera is not focusing anymore, but okay. So what do we have? Power is coming in from here. The case is grounded. We have our switch here. A slow blow fuse. Power switch. 2 transformers. Maybe one for the audio path and the other for something else maybe. It's shielded, so as not to radiate nasty stuff into the casing. Some Elna caps. This all looks like stuff to run the LEDs on the front, the LED matrices. I actually want to give that a mark to remember its orientation or take a picture, but what I very often do is I see a stripe here and I'll just mark this one wire. Let's actually like put it like some sort of stuff to. It's actually a little smooshy. Interesting. Okay, so let's turn it around. With power coming in here through the transformers. I see here 4 diodes and a 4 diode pack, another 4 diodes, some smoothing caps, another smoothing cap, a regulator, another regulator, some more diodes, some smoothing, and then we come to processing stuff. Now the question is, what reel is this connected to, and is it still shorted or is it not? So on the AC side, that looks like a cap charging. So that's probably the resistance of the two transformers together. Bring the voltage down to more reasonable levels. Well, one thing to check is this transformer is replaced. Is it the right way around? And second to that, is it soldered in properly? So I do want to take it all out. What are the two screws on the bottom for? Ah, okay. They go all the way through. Interesting. But I want to take this board out now, because I want to look on the underside. And then continue. So this will come out. Yeah, it'll be fine. Okay. So we have to if only screws were the same. Our earthing screw, this will come off clean. No, I need this one. Let me magnetize this bit. It makes it so much easier to get the screws out. There we go. Lovely little screws. Right, that's one side. Is there more? Is there more? Yes, there's more. There's one more here. There is one more here. And I think these are connected all the way through. Yes, they are. Not a long one. Nice. Here's our shielding. There's one of these screws missing here. Or, no, that's the one I just... Okay. That's really stupid. People make mistakes, right? we have liftoff almost. Yes. This one was on the top. So here we have our board. We don't need this for now. The easy part is to put in a new capacitor, but I would actually do that under the microscope, so that wouldn't make for a very interesting, or for a less interesting video. But here we are. This joint is not too pretty, but all the standoffs. Okay, so what could have happened? Well, there was too much voltage. This transformer failed. He sent me some pictures. It was all like scorched and stuff like that. But yeah, would the voltage on the secondary side become too high? Yes, that's a possibility. But why would only this cap blow? There's his power trace. Can I see? Every few channels there's the same one here, 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 and they're all jumping down. So it looks like this big trace here is connected to here. This is a ground plane. And would it but just be this cap or something else? So I'm not sure what kind of power rails are inside this device, but I see one regulator, two regulators, yeah. Is this a burr brown? Not that I know anything about stuff like that, but I don't believe burr brown exists anymore. So let me check what this is. It's a 104 FA. And here it is. Low noise, low dropout linear regulators. 1 amp. Output capacitor not required for stability. And it's only giving out is it all the same output voltage? Now here we go. And because we have a 104.5, I would suggest 104 FA5. Output voltage. What am I missing? Typical 5 volt. Yeah. Okay. Is this it? Man. Yeah. Okay. So it's a 5 volt regulator. The LM1117 3.3 volts. So let me check the pinout of this 104, and we have a DD pack. We have an enable pin. Tab is ground. It's nice. There's also a big heat sink here on the PCB, and it's actually quite interesting because this is a surface mount regulator, and they just connected this heatsink to this huge ground plane and a big ground plane here, so it dissipates the heat from the regulator like that. Okay, well, if it works, it works. There is a stabilization cap, by the way. It's not necessary. Oh, it's on the enable pin. Sorry. Yeah. No, it's on the input pin and on the output pin. So let's check for resistance between the input pin, which is on the right side, and the output pin, which is on the left side. Okay, so input pin, output pin, and I'm making good contact. 2.2 mega ohms. So that would suggest there's not a short between the input and the output of the regulator. But if I do input to ground, 5K, and output to ground, 1.1 m mega ohm. So on the 5 volt rail, it doesn't look like there's a short, and the LM17, and I don't remember the pinouts of stuff like this. Yeah, I just keep going back to, well, not all the time, but I keep going back to data sheets. This is the package. Input, output in the middle, and ground on the bottom. So input, output. It's a 3.3 volt reel. The input to the output. Oh, sorry, I have to switch transition. Sorry. The input to the output is 5K. Is that so? Yeah. The input to the ground Also 5K. Okay. I'm getting flagged. The output to ground. That's actually a little bit on the low side. This is half a K. It means 500 ohms. 600. Is this a problem? Is this not a problem? I wouldn't know for sure. But it does sound like not too much for me. How much amp can this source? 800 milliamps. It's the output current. 800 milliamps. This thing is really in the way. Let me calculate it with 3.3 volts and 600 ohms. Yeah. Yeah, okay. So maybe it's just that. But why would the cap blow? He also told me that one of the channels was not working. But I'm getting to the point where I'm not afraid to put on some power and see what happens. Not like this, but like this. How neat. There's actually not much to it, is there? This is just some op amps and some I/O. This is the networks. Some hairs. This is just more of the same stuff, so we don't really need it right now. So here we have it. This goes here. Let me check. The bottom one are the inputs and the one on the top are the outputs. Okay. I am a little bit anxious. Because especially mains is not, I don't like mains. I just don't like it. It can kill you. That's one thing. Okay, let me grab power cord. It is turned off right here. Oh, let me just quickly reset this one. So it's properly grounded now. Okay, this power pack is turned off. So it's still safe to touch now. And well, this could be the end of it, but it could also be, here it goes. And now turn it on. It's booting, cycling between the frequencies. It's defaulting to 44.1 kilohertz. It's probably not finding any firewire connection to. It's a breakout, so it's obviously not doing anything on its own. There's a slight buzz from the transformer. I actually do think the new one is actually a little bit smaller, but the markings are the same. It's booting again. There's no smoke coming out. Whoa. What I'm gonna do is I'm gonna grab the microscope and I'm first going to put in back a capacitor. It's supposed to be there, so let's put it back and see if it burns again. I don't think so. I think it was damaged because of the switch between 110 and 230. And yeah, maybe it got really hot or developed a small crack, and then next time it can just break down. Okay, so you have to apologize me for not bringing best action on camera. Because I don't have a camera on my microscope. Sorry about that. Okay, we have it here. Oh, wow. Yeah, I wish I could show you this, but that's for later when I have the proper stuff. Everything else seems just fine. It even looks like the bypassing for this op amp. Why is it over here? It's way too far away from pin 4 of this op amp. Right. So oh wow, that's really scorched. It must have been really hot. Wow. It even burned like a little hole in the pin board, circuit board. Like a perfectly round. What's on the other side? Right here. There's no components. Okay, the fiberglass pen can do wonders on filthy stuff. You don't want to use it too much because you'll remove the coating, but I am able to expose part of the trace, and it's getting shiny again. Yes. Oh, this is so satisfying. That's a good start. It was really hot for a short while. Actually, I want to get some. I've seen people use epoxy to repair the board itself. I can remove some of the gunk here and put on a new cap, but there's a hole in the board now, right underneath where the cap was, and it's no big deal. This is beer. I put beer on my boards. No, I don't. Okay. I would love to have a microscope with a camera inside, so you guys could see this. I'm logging into my parts box. It keeps my inventory, and I want to have a look for the right capacitor to replace it with, but I'm not sure where I keep it. And if you go right, I want 100 NF resistor, connector. I want it. Find. Come on, don't I have? Wait, 1 N UF. That's more like it. Yes. This is 0603, and what's on the board? Do I have 0804? 0805. Here we go. I have 10 in stock. And where is it? In the box with capacitors. So now I just excuse me. In my box of capacitors, and this is like temporary storage, because this takes too long, obviously, and I want it to be sorted at value from low to high. Well, I was looking for 100 NF. Let me just grab this real quick, because it's quicker. Is to week. I think it's 0603 on here. 10 you have 1000 picofarads, 50 volts, and 1000 picofarads is 1 NF. Oh yeah, makes sense. And 100 NF. 1 UF. 100 NF. 25 volts. Do I have 50 volts maybe? This is 100 NF. This is also 25 volt 100 NF. NF 2200. It's also 25 volts. 603, 100 volts, 100 NF. Well, that should do the trick. This is the one I want. X7R, 50 volts. This is probably the right size. So if we go back here, it's this one, and I want to remove stock just to be certain. I remove 2. Focus. It's having trouble focusing today. Was it like that all the time? Come on. There we are. Okay. Now let's put it back on. Just want to make something sure. So before I put it on, now it's out of the way, I want to check if this power wheel is actually bypassing for this op-amp. I think so, but just check that. Yes, it is. So if it happens again, then we might just have also a faulty op-amp. But it is in fact the bypassing for one of these output buffers, or whatever it may be. It doesn't really matter. Where am I? I'm here. these bypass caps are very often not strictly necessary, but yeah, it's good practice. They are everywhere. Very inconvenient angle, so I'm going to do this side first, and now when I want to put it in, where was I was here. Yeah, it should do the trick. That's one side, and now it's on there. And oh yeah, I also want to, but now I want to do the same measurement to see if there's a short between this part and yeah, it looks like the op amp is not shorted. That would be nice. Yes. And now there was also the transformer right here. Yeah, I want to touch them up a little bit, especially this. Nice discoloration. This one. This one can have a little bit more. And the other side. Ooh, that's dangerous. What is this? There's. Can you see that? The thing standing up. Come on, focus. Almost. Oh, that's not supposed to be there. It's not making any contact, but it's almost like the solder wire went through the hole and okay. It makes sense, these things need a lot of heat. Big traces, lots of metal. I also want to do this one. Oh, while I'm here, I'll just do every one of them. Because if there's intermittent contact, the resistance goes up, or could go up. That's not something we want. This one is sinking a lot of heat. And that looks much better. Nicely filled all the way to the other side. Solid contact. This one actually has extra set of shielding. One where this came from is the interface itself, and not the expander like this. Okay. I think it is time to give it another test and see if we get smoke or not. In a way, I hope we do. Another, I hope we don't. I talked to someone yesterday that I couldn't repair his synthesizer because it was too complex of an error with a synth that I don't know too well. And I told him that I would love to have the adventure, and he laughed. And I thought by myself, yeah, it is an adventure to explore an unknown machine with all its strange quirks and design decisions and how it works in general. There's so many different stuff around. They come up with crazy solutions for all sorts of problems. manufacturing problems, design problems, usability problems, price problems. Because price is obviously a thing when you build for the market, I guess. Okay, there we have. So far so good. Turn it off again. Insert some power. Here comes the power. It's pudding. Don't see anything strange. But the best way to make sure, the best way, yeah. Let me change. No. Let me change the color to this one. And if I go here. Well, the regulators are obviously hotter than everything else, but not crazy. The diodes doing the rectification. Only one pair is hot, the other is not so hot. And oh, all these op amps, it looks just fine. So what is left to do is actually test it out, but I would need another interface. I have one laying around, the MOTU. But I think it's actually just working just fine. Maybe I do want to repair the word clock. Who uses this these days? Anyone? Yeah, probably loads of people. But okay, let's actually, I'm gonna put it back together and then give it a try again. But that's not so interesting for the video, I guess. So let me wrap it up here. I consider this a fix. Thank you for watching.